Hello everyone, was a quick break. Welcome back, and right now we are going to be talking about testing. So let me bring on Nicola and her slides.
Hello.
All right, then I'll hand it over to you.
Thank you very much. I just wanted to start off by saying thank you, Chicky and John, for putting this together in these unprecedented times, as we call them. So I'm going to be talking about testing, the testing pyramid, and what does it mean for Android. So I'll start off a little bit about myself. My name's Nicola. I'm an Android engineer at Yammer. Yammer is part of the Microsoft Office 365 suite. And I've been there now for about 2 years. This is actually my first job out of college. So I still feel very young in the whole industry, actually, not just the Android industry. For instance, I don't get the joke that's on the shirt. Somebody please explain that to me. But in the last couple of years and the entire time that I've been developing software, I've learned a lot about testing. And so I wanted to take today to share my journey through understanding testing and some of the things that I've learned that I would like to share with you. So in today's talk, we're going to be going through different types of tests, what they're good for, what they're bad for, and how architecture can help you write better tests. So why write tests? Well, that is a question that took me a very long time to understand. So I started off programming when I was at university, and my understanding of tests then was not good. Tests were scary. Tests were the sort of thing that's you submit your assignment and there's a whole bunch of automated tests, and it spits out 75%, and that was your mark. And that's what tests were for. So tests was something to be feared because they were written by the university professor and they determined your final score. But then I ended up doing an internship in Sydney, and it was my first internship on Android. It's in into 2014, and I was tasked to write a feature. So I did that. I had 3 months. I wrote my feature. It was going great. I got to the end of my internship and I submitted. I showed my manager everything that I'd done, and he looked at it and he was like, "This is great, but where are the tests?" And I was like, "The what?" And he says, "The tests. You didn't write any tests." And I was like, "I was supposed to write tests? Nobody told me I had to write tests." And then I fled. They didn't ship that feature. I'm not sure if those two were related. But then anyway, so I managed to avoid that entire internship without writing any tests. But I got to my second internship. That was actually not at all Android related. It was in Python. I found out that I hate Python, and I went crawling back to Android after that. So my third internship, I ended up interning at Microsoft. And it wasn't for the Yammer team. It was actually for a different team. But when I was there, they sat me down. They're like, "Okay, this is what we want you to do during any internship. We want you to write this feature, and we want you to write tests." And I was like, "Oh no, it's time. I have to learn how to write tests." So I did the first chunk of my feature. I got it approved by my manager and my mentor, and they were like, "Okay, so before you move on to the second part, it's time to write tests for the first part." And I had no idea what I was doing, and I didn't want to tell everybody that I had no idea what I was doing. But I managed to bumble through and write some like awful integration-y sort of test. I don't think it was an integration test, but I wrote something. But the satisfaction that I got from running it in Android Studio and getting that little green tick at the end, it was surprisingly fulfilling. So I was like, you know what, tests aren't that bad. I just need to like get used to them. And then when I finally came to Yammer full-time after I finished my my time in college, I still didn't like tests. I still kind of avoided writing them. But after a little while, I finally understood why. And it's because when you're working with the same code base for more than like 3 months, tests are something that's, that help maintain the quality of the app, of the code base, of the experience overall. So to summarize why we should write tests, I managed to put it into kind of 4 reasons. The first reason being catching regressions. And this is usually done through end-to-end tests, but basically you make some change, a refactor maybe, You run your end-to-end test, and then, oh, look, this other thing that you weren't expecting has actually stopped working. So that would have been a regression if you'd shipped that to production. Finding bugs. So writing unit tests can force you to think about edge cases. Having somebody else write tests for you can make it catch edge cases that you hadn't thought about. Third one, provide living documentation. So you can write a comment saying, you know, this line of code is supposed to do this. That can become out of date. If you write a test, though, that cannot become out of date unless for whatever reason you don't run your test with every build. So provide the documentation about what the code is actually supposed to be doing all the time. And to force good code structure. So this one is particular with unit tests. Writing unit tests makes you write unit testable code. Unit testable code is easier to understand, to refactor, to work with, etc., etc. So I'm not allowed to have a talk about testing without showing a picture of the testing pyramid. So this is, I found this on a Medium blog post, and if you Google search like testing pyramid Android, you get something that looks basically like this. And my understanding is it's supposed to be about 70% unit tests. They're quick to run, they're quick to write. Moving up, integration tests. They test two units working together, middle ground, and then about 10% end-to-end tests. So they test the full coverage from the user, tapping the screen, all the way coming back to seeing something new on the screen. And those are expensive to run, expensive to write. And there's this little like bubble at the top. Sometimes it's there, sometimes it's not, about manual testing. It is a mysterious, unspecified amount. So let's go through each of the different types of tests. The first one being unit testing. So this is testing all kinds of business logic. It tests classes and functions completely in isolation with all other interactions mocked. And this is usually in a non-Android module. So the main things that unit testing are looking for is data validation. So correct values from the API are propagated, error handling. So incorrect values from the API or like, timeouts or other kind of network errors are handled and propagated. Any kinds of calculations, so mapping, or sorry, not mapping, mathing, math on processing. And then the fourth one is mapping. So any kind of like data to database object sort of things. There's a lot more things that can be unit tested. Basically anything that runs in isolation can be unit tested, but those are the four main sort of categories. Integration testing, I can only really describe with this GIF. And if you Google search like integration testing GIF, you do get some wonderful outcomes here. But basically, the reasoning is that just because two things work well in isolation, it doesn't mean that they work well together. So integration testing is testing two units, maybe three, maybe more, all of these modules together to make sure that they all behave with each other. And the final one is end-to-end testing. So that simulates the full experience, mocking the user touching it, touching the screen, all the way to the user looking at the screen again. And these are in an Android module. So I'm going to be calling end-to-end tests, or not calling them, so I'm going to be saying that they use Espresso throughout this talk, just because I have no experience with Roboelectric, but I do believe that they both work the same way in end-to-end tests. So back to the testing pyramid. I don't like this. I don't feel like this is particularly appropriate in today's day and age. And the reasons why I feel that are, I personally feel like integration tests are redundant. I think end-to-end tests do a much better job of testing the holistic approach of the app and everything getting put together. So the Yammer app does not have any processes that are largely in the background. It's a very user-focused app, and I do believe integration tests can be useful if you have a lot of background processes, stuff that the user never sees. But because Yammer doesn't have that, and I don't think a lot of apps do, I don't think integration tests are useful. I also don't think there's enough UI tests. You can miss UI edge cases. I have an example later about that. But that being said, end-to-end tests are slow, and they're usually only used for critical flows. So they're also a lot of work to maintain. They're hard to debug. They're kind of flaky. I don't know about you, but I frequently get builds failing from a Java runtime exception, no activities found. It's like, I'm pretty sure there was an activity there. So end-to-end tests should not be used to cover, every single missed edge case in the UI. So I'll go through an example of something that happened at Yammer, and this is something that I am completely responsible for. So this beautiful piece of code, this is supposed to, if a user has a name, then their avatar will show the default avatar. Otherwise, if their user does not have a name, then it will show them the drawable that prompts them to upload a photo. Except if you look at this carefully, you'll notice that it doesn't do that. And this piece of code made it through code review. Sorry, it made it through my own manual testing. It happened because I flipped this if statement at some point in time, and I didn't flip the, it was a copy paste error. Anyway, but made it through code review, and it made it out into production. And it was eventually caught by our SonaCube analysis tool that said, hey, you've got this redundant if statement. And then someone on my team pulled me over and was like, hey, what's this at? And in the defense of the people that code reviewed this, I did make some modifications for the slide. This was actually a single line if statement. So perhaps it's on me for having a line that, is over 100 characters long and is harder to review. So anyway, there were a number of ways this could have been prevented, but it fell through all of them. And so the real solution, or the real way that this should have been caught, was a test, right? Sorry. But an end-to-end test would have been far too expensive for this little widget that is part of such a larger screen, right? So I guess this leads to the more general question of how do we increase UI test coverage without drastically increasing test runtime? And other bad things that come with end-to-end tests, such as, maintainability. So I present my take on the testing pyramid, and I felt like I kind of had to force it into a pyramid shape. It looks kind of funny, but end-to-end tests on critical flows, I put it about like 20 to 30%-ish, and then traditional business logic unit tests, 30 to 40%-ish, and then something called UI unit tests being the remaining 30 to 40%. I'll go into those a little bit in just a moment, but basically these numbers are extremely flexible. If your app has more UI states, you might want more UI tests. If your app has more business logic, you might want more business logic unit tests. So these are not hard numbers at all. And in fact, I don't think any testing pyramid should have any hard numbers. But you'll also notice the integration tests are gone. They are kind of merged upwards in with the end-to-end tests. And of course, there is this mystical bubble of manual testing. And the reason why it's unspecified is because it should never be part of a build. You should never have a pull request blocked on manual testing. That gets out of hand very quickly. So you should be manually testing whenever you're building a feature or fixing a bug. You should probably be dogfooding your own app as well, or have a dogfooding team. And it doesn't hurt to do some manual testing, especially on critical flows, like right before you release your app. So anyway, back to unit testing. There has been some wonderful talks on unidirectional data flow and MVI, MVVM already. And I'm very glad for that, because I was planning on like glossing over it a little bit. But basically, all I'm looking for is, in order to make your tests, in order to make your code unit testable, you need to have some kind of business logic handler. So that being some kind of MV star architecture. So I couldn't find any diagrams that I liked. I'm not particularly fond of this one. So I spent a little bit of time in PowerPoint making my own unidirectional data flow diagram using emojis and clip art. So I'm not exactly sure what this is. I think it's closest to MVI or MVVM. But basically what everyone has already been saying before is that the data flows in one way. So basically it starts off with probably the user like tapping on your app to open their app. And then some event gets sent to some presenter or view model or business logic handler. It makes network calls or whatever, comes back. The result is mapped into a data state. And then that data state is sent to the user, and they view the screen, and then they make a decision, they tap the screen, so on and so forth. But I guess what's important is that there is a single method into the presenter and then a single method out of the presenter. Although I guess that bit's not so important. What is important is that they're all void calls. So what doesn't work and what breaks the unidirectionalness is if the view makes a request to the presenter that has some type of return. For instance, when it's rendering, it says, oh, am I in state A or state B, or do I have permission A or permission B? Asks the presenter, gets a Boolean or integer or whatever return, and then continues to render its view. That is not unidirectional. Nor is the presenter calling the view directly to make a stateful change. There are sort of exceptions to this, something called view effects or view events that aren't stateful. Things like showing a snack bar or a toast. The general rule of thumb is if you rotate the phone, should you see that event again? If yes, then it should be in the state. If no, then it should be just a view effect. And also, I didn't want to put another arrow in here because I thought it would get a little bit messy on the screen, but the view should not go and mutate the state either. So no arrow going back this way. The state should be immutable. So you're surely familiar that we tend to unit test this little red box here. So we mock some kind of event to be sent to the presenter to trigger the business logic king. And then the business logic is done. And then it's got some sort of result that comes back out. So maybe a data state or some observable or something. And that then is checked. So I asked the question that if we test the top half, why don't we test the bottom half as well? We simulate a data state, we send that to a view, we do our view assertions, and then we possibly mock a click and then check that the right event was sent back to the presenter. So same deal as unit testing, things are mocked in the section that is not part of the little bubble there. But it doesn't have the expenses that come with end-to-end tests. So I'll go through an example. So the data state is created. And by the way, I recommend Kotlin data classes for this. You can write the equivalent of a Kotlin data class in Java, but all the getters and setters are just, not fun. Actually, excuse me, no setters, only getters. But still, Java makes things not fun. I recommend Kotlin. So we create some sort of view state. And then we update the view based on the data state. So depending on how your code is set up, it might be like a view.render function, or you might have to set the live data in a mock presenter to have the same effect. And just because you have like live data set up in your presenter doesn't mean that this method here is not useful. Sometimes widgets have a render function, and the fragment or activity that is attached to the presenter will have to trickle down the view states. So this works for widgets as well. Oh yeah, sorry, you'll have to mock the presenter as well, and it might involve some kind of like dependency injection mocking too, but it works. And then we check the view. Pretty easy. So in order to test the other sort of half of that diagram, is to go and test the click listeners that are attached to that as well. So same deal, you will probably have to set a data state. You may not, but most of the time I think you would. You might have to attach a click listener to the view as well if it's not attached to a presenter with live data. And we perform a click, and then we check that click was propagated correctly. So either through verifying that the click listener had its callback called, or the presenter had some event dispatched to it. And you can combine those two types of tests as well. If you would like to insert an assertion in here to check that the view exists before you click it, you can combine the previous test with the current one. So back to this beautiful piece of code that I've written. How do we assert this behavior? By writing a UI unit test for it. So first, we fix it. This is what it was supposed to be. And also, if you're familiar with Espresso testing at all, for whatever annoying reason, you are not able to check the excuse me, the drawable that is attached to an image view. So the usual way of getting around that is by setting the drawable ID in the tag and then later checking the tag. So that's what I put in here in order to make this UI unit testable. So Same deal as everything before. We, in order to test the empty state, we make an empty view state. We set it to render. Sorry, this was a widget, so it was just a view.render call. And then we check on the image view whether or not the tag has the correct drawable ID. And same with the name state. We just sub out here using a Kotlin data class with name parameters, makes things extremely easy. So set the name, and then same deal, check that the avatar is the default avatar, not the upload avatar. So if you were to compare this to an end-to-end test, you can tell that there is quite a bit less code on the left-hand side, first of all. Because on the right-hand side, if we have an end-to-end test, when this activity is opened up, there is an API call that is made to go and check the viewer's permissions, whether or not they have the ability to edit their name, for instance. So we have to mock that, otherwise the whole screen goes into an error state, and and the right things can't be asserted. And then we have to launch the activity, and then we're able to check if the avatar is correct. If we check the name, things get even worse because there's real-time name validation on this text field. So not only do we have to mock the first call with the viewer permissions coming back through, we also have to stub the name validation call to make sure it returns, in this case, a 200, so that we don't end up in another kind of error state where the user has an illegitimate, well, unallowed name. So then we launch the activity, and then we have to click on the text view and then perform the typing action. And if anyone's ever watched their emulator perform end-to-end tests like this, you'll know that the typing action is quite slow. So this would take like at least a second to type out there. Whereas in the JUnit test, it's already there in the view state and it just renders it immediately. So in case you weren't convinced that the JUnit tests are faster, I did a little bit of data collection on here. So we had one particular widget that I wrote JUnit tests for, and there were 38 of them all up. And that tests every single field in the data class one at a time. It does not test the entire data class together. I think there was one test for that at the end that was technically redundant, but anyway, most of it was testing everything independently so that you could figure out exactly what went wrong if something were to fail. And those took around 16 to 17 seconds to run all 38 of them. And I was looking through our code and I found about 2 end-to-end tests that did the exact same thing. So I'm not advocating for the end of all end-to-end tests because there are some end-to-end tests that were with that widget that were actually useful. For instance, clicking on the button opens up a new activity or a new fragment that has a different screen and assertions on that. That is not something that can be JUnit tested. However, 2 end-to-end tests that were redundant, and they took about 5.5 to 6 seconds. So each end-to-end test, covered 2 separate cases, so I've counted them for 2. So averaging all of this out, the average runtime of the JUnit test was less than half a second, but the average runtime of the same assertion in the end-to-end test was almost 1.5 seconds. So doing a bit of math, thank you very much, Excel, comes out to over 300% faster. So this looks great, but then if you look back at what I've said earlier, where I wrote 38 JUnit tests and only 2 end-to-end tests, you might ask the question of why did you take two tests that took less than 6 seconds and then turn it into 38 tests that took 17 seconds? It actually looks like your build's going to take longer now, and unfortunately, you are correct. So the theory here is that every end-to-end test that is, every end-to-end test can be replaced with 3 more JUnit tests, approximately, that do the same thing or test even more. So if you have end-to-end tests testing every single code path possible, then you'll save loads of time. That's great. If you don't have any end-to-end tests because end-to-end tests are hard, then writing JUnit tests is going to increase your build time. Unfortunately, there is no compromise in there. They are still UI tests. They do still spin up an activity, albeit you can spin up a dummy activity, something that is stubbed to be very empty, if you're only attaching a widget to it, so it doesn't take that much longer, but these things do still take time. So hopefully you can improve your test coverage and decrease your time, but it will depend on your current test coverage. So I'm going to jump train a little bit here and talk about how we are running these tests. So to run UI unit tests, you'll probably want JUnit for mocking, JUnit for running, Mockito for mocking, and Espresso for asserting. This is what we use at Yammer. This is what I'm most familiar with. I've also heard good things about Mock-K. And you also might need assert-J for testing if the callback has like parameters in it or something. You might want to do an argument capture and a JAssert on that as well. If you want to run your end-to-end tests, you'll still need JUnit for mocking. Excuse me, you'll still need JUnit for running. You'll need some kind of test rule to mock your API returns. Thankfully, when I got here, somebody had already set up a whole thing about test rules, so I didn't have to deal with that. And you'll want Espresso for asserting, and there is no assert-J in here. And so running unit tests, JUnit for running, Mockito for mocking, assert-J for asserting, and this one has no Espresso in it. However, there are some issues that I have with JUnit that, and I'd like to propose a possible alternative. So if you're doing this talk in real life, I would ask anybody if they'd heard of Spec. So if you could, humor me and do a hands up at home, who here has heard of Spec? In case you haven't, which I assume you haven't because I don't hear much talk about it, Spec is inspired by Cucumber IO's Gherkin syntax. So Gherkin syntax is something that explicitly calls out given, when, and then in full sentences. Given meaning the setup or arrangement that is required, when meaning the execution and the act of the test itself, and the then meaning the assertions that come with that. So basically, it looks like something like this. So given a feature, I've given the test of a typical mutable set, and a scenario is that we're adding an item. Given an empty set, when an item is added, then the set contains the item, and then the set has a size of 1. And the reason why I'm quite fond of these sorts of this sort of syntax is that you can sit down with your designer and with your product manager and show them these things written in English that everybody understands and ask them to check if this is what the product is supposed to do. So if you were to take a typical JUnit test for something like this, it would look like this. So you'll notice that my favorite part of writing JUnit is the awful function names that sometimes come out of this. So we arrange the set. We also initialize a test item. We add it, that is the act of the test, and then we assert that the set contains the item, and then the set size is equal to 1. And you'll also notice here, I have left out that inside the function name that we are also checking that the item is contained within the set. Because if I were to write that in there, we'd end up with the function name all the way over to the side here. So if this test were to fail, specifically on this first item here, it's not inherently obvious at first when your test results come back and this function name is what's failed, what's actually happened. So if we were to convert this into a spec test, yes, it does take more space, but we have here the feature calling out the set. What we're doing, we do our initialization here in this given. The when is adding the item to the set, and then there's two separate then statements for the two separate asserts that say what the test is doing. And they're also in full sentences as well. I encourage people when writing spec tests to write a full sentence, assuming that the word given, when, or then starts the sentence. So if this were to fail because the set did not contain the item, oops, sorry, I didn't mean to go back. Excuse me, if this test were to fail because the set does not have a size of 1, we get an error like this. So we can see in here all the nested sort of situations. So with a mutable set adding an item, the set has a size of 1 was failed. And then we've got the output from the assert J on the side here telling us what the size actually was. And so these full sentences help us to sort of diagnose issues a little bit better instead of opening up the test and then trying to figure out like what actually failed. So to summarize, UI tests. Ooh, that's a typo. Excuse me, that's meant to say unit tests. Unit tests 40%. I recommend spec for running, but JUnit also works just fine. Mockito for mocking, assert J for asserting. UI unit tests 40%-ish. as well. Depends on how many widgets you have, how important your view is, and how different it can be. JUnit for running those, Mockito for mocking, Espresso for asserting, End-to-End Test, JUnit for running, test rule for mocking, and Espresso for asserting, and integration tests, put them in the trash if you can. If you can't, so be it. But if you can, I recommend not doing them. So you'll notice that I only said Spec for running the unit tests, though. And I know that Spec does have support for running tests in the Android module, i.e. UI unit tests or end-to-end tests. But unfortunately, I was never able to get that to work. On the Spec Framework's website, they actually do say that you need a third-party plugin in order to get it to work. I tried. I set it up, and it was full of warnings. It wouldn't actually compile in Android Studio, but it would run in the command line, which I don't like running tests that way. I upgraded Android Studio at one point. It just absolutely broke it. So I decided to, well, the team and I made a decision that we were going to wait for an official plugin and support from Spec to get that running for UI tests. And unfortunately, we're still waiting. But if anybody was able to get Spec running with anything in the Android module, I would love to hear about that. Please let me know. So before we get into the question section, there are a couple of things that I missed that I was not able to figure out where to nicely put into this presentation. So I'm going to ask some questions and then answer them myself. And the first one I kind of mentioned a little bit before, but do UI unit tests work with Roboelectric? And the answer to that is I have absolutely no idea. I really hope that they do. I've only ever tested this with Espresso. I'm pretty sure it should all be the same, but I do not make any guarantees. Again, if anyone wants to try out the idea of a UI unit test with Roboelectric, please do let me know. I would love to hear about that. What about testing for accessibility? Well, UI unit tests can test things like content descriptions. So the reason why I set a tag on that example before was because that widget was actually not important for accessibility. And so setting a content description wouldn't have made any sense. But you can assert content descriptions with UI unit tests. But if you came to 360 and Dev last year, you would have gone to my talk about accessibility and how it is so much more complicated than content descriptions. And accessibility is always best tested manually because there is just so much more to it. So yeah, you can test content descriptions. I'd recommend it if you do have content descriptions set, but don't think you can do that and call accessibility done. When should we mock network calls? And I think always. So except for when you're manually testing, of course. And the reason why I feel like I had that opinion is because the server can be flaky, and you don't want your tests to fail for something that was not at all your fault. So I guess in order to make sure that people don't come at me angry, is that I do think that you should be scraping all of your data for your end-to-end tests and for your unit testing and anything that requires mock data, scraping that from real examples, but store that locally. Don't rely on the server sending you correct things, especially for testing mutations. It gets a little bit funky. So I always think you should be testing with mock data, but make sure that when you're manually testing, which should be when you're doing your own development, when you're dog fooding, when you do a release, that everything works as expected. But I don't think contract testing should be something that is on the client teams. But if your backend team tells you that contract testing is your responsibility, well, maybe it is something that you should be doing, but it should not be included in your regular builds. And with all that, I will put it on to real questions.
All right, thank you, Nicola. Let me just show it like that. Wow, I love that you tied it back to your talk from last year. So as always, the questions will be asked on Slack, and I think there are a little bit of confusion. So it's not really a question per se. I'm going to just read it out loud. Maybe you have some comment. Basically, it's a discussion of all this terminology, like UI unit test and integration test. So I'm going to read it. Maybe you can read it too, because maybe easier to read. So basically, someone was saying that the activity test rule seems like it depends on Android context. I always thought that if you have a unit test that's going to rely on the context, you have to write an end-to-end or an integration test. So basically, just kind of trying to wrap their head around integration, end-to-end, UI unit tests. I'm with you that the pyramid is confusing. So maybe in YAML, like how do you kind of use?
Yeah, sorry, I'm just reading this again right now. So unit test that's going to rely on context, you have to write an end-to-end test or an integration test. I never heard that. I have written tests that rely on activity test rule that I did not have an end-to-end test for, and the police didn't come for me. So I don't think that you have to do that. If you would like to have if you'd like to have that set up, then that sounds good. More testing is always better, but again, it comes at the cost of your build time.
Right.
But yes, the UI unit tests do depend on the Android context.
Yes. I think that's kind of the confusion there. Like the fact that it is dependent on context, but not an end-to-end test. So I think that's what you mean by UI unit test. So it's testing a unit not end-to-end, but it still depends on the Android context, and therefore there's some certain UI element that you have to pull in.
Yes.
All right. So let me just see. Yeah, this is again not necessarily a question, but kind of do you have a preference in terms of using like the Espresso-based testing versus the Android X version that uses activity scenario and fragment scenario?
I have not used the Android X activity scenarios, actually. That is something that I will add onto my list to look into.
Right. Yeah, I mean, that's the thing about testing, right? It's not a static thing. Like you have, so that's why I try to frame it as like, what did you do with your team and how did you tackle it? I myself keep thinking that I should try all this scenario thing, and then, but it ain't broken. Why should I try to jam something new in just to try it? So just in case you have some experience, I want to bring that up. All right, then. I think that's all for the questions I see right now. But of course, the Slack channel is still available. So if you want to discuss among yourselves or you want to ask Nicola questions, please go ahead. All right, then. We will have time for a break, and then we'll come back in a few. All right.
Thank you very much.
Yeah. Thank you.